Doing a video for YouTube. So this is basically literally the first mock-up of my homemade heat pump water heater that America refuses to sell to us, other than Sanden, which is like $5,000 crap unit, which has horrible efficiency at cold temperature and very poor output. So what I'm using here, it's gonna be a lengthy video just up ahead. This is the LG HYV3, their newest unit. It's a 12,000 BTU, so it runs about 1,600 bucks. I think I got that shipped to my house. So what I did, if anybody has taken these apart to at least clean them, you understand how these work. This is the indoor head. There's no brains in here. With a mini split, everything is done outside. This is not like your regular home air conditioner where you have a TXV or EV in it. On mini splits, everything is located outside, and your condenser is there, and your evaporator starts as soon as your coil starts. So no modulating valves in here. All I did is I removed from here, this is the mid-pipe sensor. Why it's called mid-pipe is because this is hot freon. It's going to be coming in from here, and it goes where the suction line goes, so that's your hot line. It goes through 24 inches, comes back through 24 inches. The computer gets a reading halfway after it received removed half of its heat into the evaporator, and then it goes again for another 24 inches, and then it comes out as a small pipe back into your liquid line as a returned cooled off refrigerant. Nothing else in there. The other thing that I'm gonna have to move the other thing that I'm going to have to figure out is if I'm going to use the original temperature sensor to let it run, but I don't think I'm going to do that. I think I'm just going to do a hard on-off. I know everybody's going to say that's bad, but it's designed to be shut off hard and turned on hard. So if the power goes off, it'll turn right back on to the same setting. What I'm going to do is I'm going to wire one of the electric water heater's switches that you can set to whatever temperature you want. I'm going to wire this 240 to the mini split. So when that says, hey, I need heat, that's going to turn on. And it'll go right back to the same setting that I have, 86 degrees. This has been running for about an hour, so I'm going to giving you, an hour update. No error codes, no nothing. This thing has no clue what's going on, because everything goes on the outdoor unit, like I said. Nothing happens in here other than the exchange of heating or cooling. That's it. You can hear a little bit of vibration because the pipes are rattling, but it's practically silent. What I have in here, this is a 3/8 line, because that's the suction line. That's the large line that sends the heat. I measured how many feet there's in there. So there's about 90 feet of 1/4 inch tubing. So what I did is I put 90 feet of 1/4 inch tubing into my water tank. I coiled it. And I mean, this is a mock-up, like I said, so I'm going to remove it. So I have PEX tubing. I zip tied it. So it's 90 feet of about 2.5 foot coils. That's about the width of the coil. I chopped off, grinded off the top of this tank, so I'm going to be welding that back on. It's an 80-gallon tank. Most of the coils up top, that's what I've noticed most heat pump water heaters from the stores have, but they wrap their coil on the outside, way less transfer of heat. I'm running it right inside. As it gets to the bottom, there's less and less, because I'm mostly heat up top. How I'm doing this, so 3-way, this is originally screwed into the water heater. I put a 3-way in, reducer from a 3/4 inch to a 3/8, and then from a 3/8 I have to a pressure fitting of a 1/4 inch. I had to drill this through completely because this line is designed to go in and stop, and then you have your compression fitting you put on and tighten it. I drilled it through and through because this line goes through and through and it runs in. Same thing is going to be up there. I didn't do that because like I said, this is a mock-up just to see if it's going to give me any error codes. If it's not, I'm going to make it, the way it's supposed to be. I'm going to zoom out a bit. No issues whatsoever. So my shop's about 70 degrees because this is cooling. So it's dropping the temperature slowly, but it was about 75 when it started. So this line will run at about 150 degrees. It's always 150 once it gets up to its 8 amps at 240 volts. This line, when the water was cold, so I put 40-degree water from my garden hose into here. That was like 70 degrees in the beginning. So the heat transfer is very good. Obviously, as it got warmer, you guys won't believe it, but I'll show you the top's about 145 degrees right now. As it gets warmer, This line is about 105. I checked it. And this is the line that I put. This is the return line where the heat is finished coming off the piping in the water. This is where I put the mid-pipe sensor. Because I tried to put it up there and it wasn't giving me the temperature I was looking for. So I put it back here and no error codes. It's running at 150. If anybody's concerned, there is a protection. So the temperature in here is also measured on the outdoor unit. It will never let it get over about 160 degrees if you read engineering manuals. That's about what it locks out. So no matter where I put this mid-pipe sensor, the hot line will never get over whatever the brains inside of the outdoor unit want it to get over. So, you know, there's no worry about frying anything. So then this line is going to run, you know, outside. Both of these are going to run through a wall and outside where this unit is going to be, the outdoor unit is going to be. Like I said, I know I totally mocked this up. There's 240 running through here because I just need to get this done to see if there's an issue or not. What you're going to look over here. So it's pulling 6 amps. It was pulling about 8.5 like it's supposed to. I can tell you in heating it'll pull about 8.7. It was pulling that until I literally started the video because I'm assuming this line is already returning hot enough refrigerant where it's the compressor saying I don't want any more hotter refrigerant, so it's tapering down its ability to produce heat. It's wired in just like it wants to be. The only thing that I'm going to do when I put it in my house is I'll put this in my boiler room, but I will take it apart and I will disconnect the fan motor and just let it spin on its own so that there's no, I don't need no air blowing out of here, you know. I'm going to let it turn on and hang on the wall like it, you know, the computer wants it to do its own thing, whatever, move its flaps. But the fan motor is just going to spin itself. You know, there's no point of moving air around in your boiler room. So we started, this is on one leg, just so you guys know. So we started, I zeroed this system out. So we pulled 2400 watts right now on an 80-gallon tank with no insulation on top. I mean, I threw some bubble wrap. So I'm going to turn this on. This is a temperature sensor right here. Let's get it on Fahrenheit. So that's about 67 in the shop. I'm going to throw this on the top. You guys won't believe how hot this is. So let me just set this up because I'm doing this all by myself. Let's drop this in here. Here you go. I know it's the top of the tank, but look at that, 150 degrees in about an hour of working. Let's bring it down lower. Let's bring it down as low as this thing will go. And then we'll measure what the temperature is in there. So 125. And let's see if we can go lower. And then what I'll do is I'll pull it out and I'll see how deep we put it. Hope I don't ruin this thermometer. Wow, it's really steamy. So, this is how deep we went. So the tank starts about here. So we went to about the halfway point. I know this is a crappy video. So we went to about here. So the water is still 135 degrees here. I understand it's going to be probably 100 degrees there right now, because that's measuring about 105, and this is, you know, 6 inches sticking out from the tank. If this thing ran for 1 hour with 2 elements, it would pull 10 kilowatts. I pulled 2 kilowatts. 1:5 ratio. 1:5. And that's with a whole bunch of heat loss through here, because this is not insulated. I know you're going to say refrigerant move fast, but I've tested it. Simply checking the temperature there, and then after this coil over here, it's around a 5-6 degree drop already. So I got to insulate all of this and cut out whatever I don't need. And, you know, there'll be more heat going into there. So 5.5 or 6-to-1 ratio of what the system pulls and what it pumps into there. Way better than any heat pump water heater you're going to buy from the store. I have one in my house. I have the GEs, the second generation. The first ones, they're made in China and they failed. I have the second gen. I already changed the fan first one time because the fan's motors blow out on them. But what I don't like is that it is very slow to recuperate. Got a couple kids, you want to take a couple baths and showers, you do not have enough hot water. Or if I run it on straight heat pump, by the time they take their baths and showers, that's it. If you run, you know, do your dishes, you're out of hot water. This thing, I know it's 12,000 BTUs, This thing will give you 22 or 24,000 BTUs, 47 degrees or above. There, you can go on websites, they'll tell you what its ability is.